This screencast is part 5 of a video series called Building the Nominal Test Case using Zuzena. In this video, we will focus upon adding test evaluation steps to the test case we've been building. These evaluation steps will examine the results of the ETL called by the test scripts that we added during the prior video. Using these evaluations of the transformed data, Zuzena will determine whether the test case passed or failed. At the end of the presentation, we will display links connecting you to the other videos in the series. Remember that in this video series, we're building a nominal test. The nominal test case proves that all your data warehouse transforms work as expected when given data that's trouble-free and supposed to load normally. At a future date, we'll post some other videos illustrating the smaller test cases you'll need in order to demonstrate how your ETL responds when it contains defects such as missing reference records or improper values. In the previous videos of this series, we provided an overview and illustrated the first steps in creating a Zuzena test case. We introduced the capabilities of the Zuzena test engine and listed the goals of the test case we're building. We demonstrated how to create the blank test case container, label it with metadata tags, and add data staging steps. We also showed you how to run that test case individually and as part of a test suite. In the previous demo, we documented how to call data transforms using SQL statements and ETL engines. You probably noticed, however, that the test case at the end of video 4 only transformed the data. It made no effort to determine whether the ETL produced the right results given the source data it started with. In this video, we'll add calls to the evaluations needed to determine whether a test run of the ETL has passed or failed. Let's start at Zuzena's main menu. Click on Test Cases to bring up a browsing screen of the tests that you have already defined. Enter a string in the search bar and then click on Search to filter the test cases to just those you are interested in working with at this time. This is our nominal test case here. Click on its short name code to open up an editing screen. This test case is essentially as we left it at the end of the prior video. You can see that it still has its 4 metadata tags that let us include it in any number of test suites. Scrolling down, you can also see the staging routines we added earlier. These staging actions pull data out of a source repository and place them in the data warehouse's staging area, so that the ETL will have the right starting context when it is invoked. Here's the section where we added 2 test scripts during the prior video. The first action step used a SQL statement to clear records from the target tables. The second one called an ETL workflow to reload the tables based upon the newly staged data. This test case will require 2 evaluation steps before it knows whether the ETL transformed the input records properly. The first evaluation will employ an analytical approach to determine whether the ETL processed all of the staging records. The second will use a set of expected results to decide whether the data transforms generated the proper values. Note that analytical evaluations and expected results are 2 very different approaches to evaluating the outcome of a test script's action steps. The truth of an analytical assertion can be determined by looking at the input and output of a data transform without knowing beforehand what the target value should be. To determine whether your ETL processed all source records, for example, your test evaluations could ask simply whether the count of the staged records equals the number of records found in the target table. However, many of the business rules that ETL packages implement are so complex that a test assertion would have to duplicate the logic of the ETL to know whether the data was transformed correctly. In these cases, it's more efficient for the developers to take a set of sample input records and research what output they expect the ETL to generate for them. These results are saved away in an expected results repository. During the evaluation portion of a test case, Zuzena will need to simply compare actual target records to expected results in order to determine whether the ETL performed properly. In order to validate the ETL module we're testing, we have to understand something of what it does. As a reminder, here's the star schema that ETL happens to be loading. First, the ETL aggregates the many billings for individual weeks and the diverse set of customer segments and geographical regions down to a single value per analytical cell in the revenue star schema. Second, it looks up the surrogate IDs for non-numeric qualifiers such as customer and market, and links each new fact record to the appropriate instances of the dimensional entities of the warehouse. To check that the revenue values were captured accurately, we can use an analytical assertion that compares sums in the source to sums in the targets. To ensure that the fact records were linked to the right set of dimension records, it will be easier to use a set of expected results rather than an analytical script. On this project, our developers have prepared a set of expected results for us to use for evaluating the fact table we'll be loading. Note that this one fact table links to 5 dimensions, including billing date. Let's return to our sample test case. We've already added to it the first evaluation, the one that checks that the ETL didn't skip any input records. Open up this evaluation by clicking on the pencil icon to the right of the Compare Billing label to open up the editing window for this test case component. We can't just count records in and out because the ETL we're evaluating aggregated records into weekly revenue amounts by product, market, channel, and customer segment. So in this case, we need to confirm that the sum of all the billings found in the source files matches the sum of the billings loaded into the target tables. We could do all the work with SQL sum commands, but here we utilize one of Zuzena's built-in test assertions. Zuzena offers the tester many predefined assertions such as equal rows, which will check that the records in both source and targets are identical. It also provides checks that source and target datasets have the same number of nulls or unique records. For a majority of your tests, you'll be able to simply check one of these built-in assertions and Zuzena will literally write the test for you. In our sample test here, we have chosen the equal sums assertion. So all we have to do is identify for Zuzena 2 data streams, and the test engine will ensure that the totals between them are identical. First, we used a SQL statement to specify an expected value for Zuzena to match. Here, our expected value will be the total of revenue from 2 input data sets, one from the Northwest region and the other from the Southwest region. Notice that we used a constraint to narrow the range of records considered, using the same time point token value we employed when staging the data and calling the ETL. Next, we provided this simple SQL statement to generate a stream of revenue amounts from the target tables. Given these streams of values from both the source and target tables, the equal sum built-in assertion will cause Zuzena to check that the total billings in both are the same. Let's close this editing window and start thinking about the next evaluation step we want to add to this test case. If we turn to a database console window, we can inspect the tables that our test assertions will be using. Here we see the structure of the target fact table, F weekly billing. You can see it has 1 numeric column for the total billings and 5 columns of foreign keys to link each fact record to the dimensions of the star schema. Here's the structure for the expected results table our team built for this fact table. Note the TRR prefix on the table name. It stands for Test Results Repository. Note also the metadata columns that begin with the ACIT prefix. The values in these columns align with the values the development team uses for the test case aspects that we discussed in video 2. They let Zuzena retrieve the subset of expected test result records appropriate for the scenario being tested. This metadata-based subsetting allows us to store expected results for such situations as initial loads and incremental loads, all in the same table of test data. Returning to the Zuzena interface, click on the green plus sign to the left of Add Another TSR Test Case Evaluation. That creates an empty line in the evaluation section of the test case container. If we had already created an evaluation for another test case that we wanted to reuse here, we could select it from the pull-down menu to the right of the assertions code name. Because the assertion we want doesn't yet exist, click on the green plus sign to the right of the label field to open up an editing window for this new evaluation step. Give this new evaluation step a short code and a description. We will identify the two data sets that we'll be comparing in a moment. For now, we just want to tell Zuzena that it should check that those data sets are identical, row by row, column by column. So select Yes for the equal rows built-in assertion. Now we need to identify the expected results that we want Zuzena to match. Specify that we'll be using a SQL statement and not a shell command. Then provide a database connect string. Now enter the SQL command that will generate the expected results record set. Here we're using two of the metadata columns of the expected results repository to filter the expected records to just those that pertain to the nominal test case and the particular time point we just loaded. Note we had to translate the metadata value for time point into a key value since the data dimension is organized by surrogate IDs, which is standard practice in the data warehousing community. Move down to the actual results section and again specify a SQL connection. Provide the SQL command to create the collection of actual result records you want compared to the expected results. Note that the columns have to be in the correct order to match the layout chosen in the first SQL command for the expected results. The sort order must be the same as well. Save this new evaluation step. We're almost ready to run our test case to see if our evaluations work. Remember to set the run order on this new evaluation so that it will occur after the data staging and ETL calls when Zuzena executes this test case. We've got 8 other steps, so give this evaluation a run order value of 9. Save the updated test container, and let's try executing the entire test case now that it's complete. We'll start up the test case like we did in the earlier videos of this series. Check the test case in the leftmost column, choose Run Immediate from the pull-down menu, and click on Go. Refresh the screen to see whether the test case passed. Click on View in the Run Results column. Now click on the log file name of the latest test run, which Zuzena displays at the top of the list. The beginning of this run log is very much like we've seen in the earlier videos. During its execution, the test case has performed data staging and ETL action steps. When we scroll to the bottom, we find the console output from the 2 evaluations we've added to this test case. Here's where Zuzena compared the 2 streams of billing amounts. We can see that it was looking for equal sums and that the data it found met the assertion. Below that lies the outcome for Zuzena's comparison of actual foreign keys to the expected values. The log recorded that it was looking for equal rows. Here we can see that it compared the 2 data sets row by row, column by column, and that this assertion also passed. Finally, the log shows that all steps of this test case succeeded, including staging, ETL calls, and evaluation of results. Because they all succeeded, Zuzena labeled this run of the test case as a pass rather than a fail. This 5th video about building a nominal test case focused upon adding evaluations to the test case container. First, we discussed the difference between using analytical test assertions versus comparing actual ETL outcomes to a set of expected results. We then used Zuzena's graphical user interface to open the test case container and examine an analytical assertion that compared the total billings found in input datasets to the values loaded by the ETL into the target table of the data warehouse. Next, we created a new assertion that validated the foreign keys set by the ETL by comparing the actual keys found in the target table to those our team stored earlier in a table of expected results. Finally, we ran the test case and examined the console output, showing that Zuzena executed both test assertions, found they succeeded, and then labeled the test case run as a pass. This completes our video series illustrating how to build a test case using Zuzena. Test case happened to be a nominal test case, one that demonstrates how the ETL behaves when given records that should load. Look on the web for additional Zuzena videos that document how to adapt the nominal test case to address situations involving less than perfect source records, such as missing values, poor formatting, or unacceptable values. Use the links on this page to open other videos in this series. Be sure to contact us with questions concerning test automation for data warehousing, business intelligence, and big data application development. Thanks for watching this screencast, and good luck with your projects.